Greetings and salutations. Welcome to the product property of logarithms. So to understand the product property of logarithms, it might be useful to look at a numeric example. Say we have log base 3 of 243. Now, why would I choose this as one? It's the numbers I chose. So, just have to cope with that. Remembering that log base 3 of 243 is asking the question, 3 to what power equals 243? Well, 243 is actually a multiple of 3 many times. It's actually 3 to the 5th. So when we ask the question, what is the value of this? It should be 5. So we're going to see if we can get that same result another way. Starting off again with log base 3 of 243. Now, 343 can be broken up in a bunch of different ways. The way I'm going to choose to break up 243 is to say that 243 equals 9 times 27. I'm using those because those are pretty common multiples of 3 that we are more comfortable with. Okay. So if that's the case, then log base 3 of 243 can be written as log base 3 of 9 times log base, or times 27. Now, we know this is supposed to equal 5. So I'm going to look at this using the product property. The product property, which we're going to prove in just a moment, says if you have a product inside the argument, you can rewrite that as two separate statements, or however many things are being multiplied, like that. Log base 3 of 9, we're going to actually answer the question this way. And this is just showing that it does work for this particular set of numbers. 3 to what power equals 9? 3 to the what equals 9. So this is equal to 2. 3 to what power equals 27? 3 to what power equals 27? That happens to be 3. 2 plus 3 is 5. And so we see that, yes, in fact, this does work. Now the question is, why does it work? So let us go back to a situation where we start with a statement like this. M equals b to the x, and n equals b to the y. Those are just two statements, and they can be absolutely true. So we're just going to set them up. Those are our lets. Now, for reasons that should become clear soon, I'm actually going to take this equation, and I'm going to multiply both sides by n. So I'm going to take this and get m times n. When I multiply both sides of the equation by something, as long as it's the same thing, I can multiply it by that same thing, no matter what that thing looks like. So n can also be written as b to the y, as I've defined it just like that. So b to the y. Now I'm going to simplify this expression so that it's a little easier to write. When I have two things that have the same base that are being multiplied, I add the exponents. All right, that's the property of exponents that we've been working with for quite some time now. Okay, so now I have these three statements. I'm going to take each one and I'm going to rewrite it as a logarithmic equation instead of an exponential equation. So rewriting this one becomes log base b of m equals x. B to what power equals m. This one, log base b of n equals y. Same idea. And then we'll rewrite this one, log base b of mn, that's the product, equals x plus y. Now, if you take a look at what we've got here, right, we've got a statement for what x is equal to and a statement for what y is equal to. So I can substitute for x and y with what they are equal to. X is log base b of m, and y is log base b of n, which is the product property of logarithms. If you have a product in the argument, you can split it up into separate statements with the same logarithm operation, same base, but as a sum instead of a product, which actually goes back to what we saw up here. If I think of rewriting this as 9 and 27 as 3 squared and 3 to the third, when I multiply those out, I'm going to take the same bases and add the exponents. So when it's a product with the same bases, I add the exponents. This is a product with the same bases, add the exponents. Hope that helps a little bit.